All right, let's discuss weight. Weight. The definition of weight is the force caused by gravity acting on a mass. So, weight. The force of gravity acting on a mass. All right, normally the weight of an object is the same as mg. But when you get into some situations where we start accelerating a reference base, then we have some issues. So let me go ahead and explain this to you. Force of gravity, which we know as weight, it's also on that formula sheet that I gave you with all the forces, is mass times gravity. Mass is always in a kilogram, and gravity is always meters per second squared. And normally I refer to the force of gravity or weight as mg. I'll call it mg a lot. So let me go ahead and give you an example. So when we talk about weight, normally what people do is they stand on a scale. They stand on the scale to get their weight. So I have the ground here. I'm going to put a scale, and here you are, standing on the scale. Well, if I did a free body diagram on you, on the scale, we get F of G, which is your weight going down, mg, and coming up, we have F of N. Now, what the scale is telling you, in reality, is not how much gravity is pulling you down, but what the scale is telling you is how much it is pushing you up. And if you're not moving, then your forces are balanced, which means that mg is the same of F of N, and you kind of figure that's how much you weigh. That's a good question. And so we can also get weight from another way, kind of like in the grocery store. So in the grocery store, usually from the ceiling, you have a spring or a string and attached to the chain, or a spring is, hang on just a minute till after the, okay, so the announcement's over. So you have a little scale, and then the scale might be attached to some string, and it has a little sensor, a little meter here. So suppose I attach you, and here you are, you're desperately hanging on to this string. Well, again, if I do a free body diagram on you, I have mg, which is gravity, and then I have tension, which is F. And usually what this reads is the tension in the string. If you are not moving, if you're not accelerating at all, then the force of gravity is the same as the tension, and you get how much you weigh from this way. So you can get it from the normal force, or you can get it from tension. This is commonly what you see in a grocery store when you're doing vegetables or fruit, and this is the scale that you have in your bathroom. So why don't we play around with the situation here and have a little fun? This situation that I just covered says the sum of my forces is equal to 0. The sum of the forces here is equal to 0. When the sum of the forces is equal to 0, one of two things happen. Either you're not moving, or you're moving at constant velocity. So here you're not moving. So that's how we know all the forces are equal. So let's play around with moving the frame of reference. Then we're going to have a little bit of fun. Alright, well, now I'm going to take you, I'm going to put you in an elevator, and here's a scale, and you're standing on the scale. There you are. Well, let's have a little fun. Let's say the elevator is accelerating upward, and I'm going to designate up as positive acceleration, because for us the initial motion is always positive, and my elevator is going up, and so up is positive. Well, I'm accelerating up, so the sum of the forces equals ma. It doesn't equal 0. I'm accelerating. Well, let's sum the forces here. Well, if I do a free body diagram, and I'll draw it over here, I have f of g, and I have f of n. Those are the forces on you as you're accelerating, except now it's not 0, it equals ma. So I'm going to say f of n minus mg, which is the force of gravity, equals ma. Here are the sum of my forces, and the sum of my forces equals ma. Well, what would you expect? If you're in an elevator and you're going up, you feel heavier. So let's see if we can get the numbers to verify that. And again, remember, what the scale is reading is how much it is pushing back on you. So it's reading your normal force. The scale is reading the normal force. Well, f of n is equal to, I'll move mg to the other side, m times g plus a. Well, now this is bigger than f of n, so you weigh more, you're heavier. Let's do a scenario where you are moving down. So put you back in an elevator. Here's the scale. Here you are sitting on a scale, and now we're accelerating downward. Okay, and I'm going to say down is my positive acceleration. Sum of my forces is equal to ma. Let's sum the forces. To sum the forces, let's do a free body diagram. And again, I have force of gravity, which I often call mg, and I have normal force, which I call Fn. But since down is positive, that means f of g is positive. So I'm going to say f of g minus f of n is equal to ma. And I'll break this down to a bit more detail. Well, let's do a little bit of algebra. Then I'm going to say m is equal to, let's move this over there, move that over there, and I'll say it's g minus a is equal to f of n. So now you weigh less. The scale reads less here. The scale reads more here. Can you get the same results from the scenario where you're hanging on a string with tension? Sure. F of n all of a sudden becomes f of t. And I'll do that really quickly. So put you back in an elevator. Now I have my scale. I have a string. And there you are, frantically hanging on to the string. We're going to accelerate you upward. If I do a free body diagram on you, I have gravity down and tension up. Tension up. I'll say upward is the positive acceleration, so my equation, sum of my forces, is equal to ma. I'm accelerating. This would be f of p minus f of g is equal to ma. Let me write this out in a bit more detail. F of t minus mg is equal to ma. Do a little bit of algebra. F of t, which is what the scale is reading, is that tension pulled in the string, is equal to m times g plus a. When you go up, you're going to be heavier. That makes sense. Let's go down. And there you are hanging onto the string. We're going to accelerate down. I'll say down is positive. Same free body diagram. Same basic force statement. Because I am accelerating. Now it looks like f of g is positive because down is positive. So f of g minus f of t is equal to ma. I'll break this down to some more detail. Mg minus f of t is equal to ma. With a little bit of algebra, I'll say m times g minus a is equal to f of t, and you weigh less. So either you're standing on a scale or you are hanging on a spring scale, you get the same result. You have to pay attention which way A is going because that dictates what's positive and what's negative. So this was pretty short, 10 minutes. Take some time to absorb what we're saying, see if it makes sense. And tomorrow in class, we will talk about Atwood machines, and we'll put this all together. So I will see you tomorrow.